Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Assalamu alaikum wa rahmatullah. Welcome to this first session of your subject manufacturing processes and 220. Previously, this course was known as production engineering. In this semester, its name has been changed to manufacturing processes. So, in this first slide, we have some general information about this subject. The knowledge area we are going to deal with is the core breadth. Means we have large number of topics without going into much details of each topic. We have the credit hours of 3+0. We don't have any dedicated lab session for this subject, although we will be doing with some workshops for you to have hands-on experience on certain processes. There is no prerequisite for the subject, as it's a core breadth, it's a beginning subject, and I am your teacher, Sayyid Muhammad Hassan Liaquat. And should you have any question after this lecture or during this semester, you may reach me at the Google Classroom. Now let's start with this. The books. I have already uploaded these books on your Google Classroom. The textbook we will be dealing with in this semester is Fundamentals of Manufacturing Processes, Materials, Processes and Systems by M.B. Gruber, 4th edition. And the reference book you can use for your ease, or we may refer to sometimes in our subject, is the Materials and Processes in Manufacturing. It is also known as De Garmo's book. Okay. The CLOs and the PLOs, the course learning outcomes for the subject, we have the 4 CLO. The first one is discuss in detail the processes of manufacturing of metallic and plastic parts, and it is mapped with the PLO1. We have the second CLO as compare different types of metal forming processes and differentiate between their output products and characteristics. The third one is describe different types of joining processes and introduce the concept of sustainable manufacturing. And the last one, the fourth one, which we will cover in the workshops, that is contribute positively at the individual as well as the team level. So you have to perform certain duties as a team and as well as individual jobs in the workshops. So what is the CLO1? Discuss in details the manufacturing processes of metallic and plastic parts. In this CLO will cover the following chapters. Chapter number 10 of your textbook, that is Fundamentals of Metal Casting, and the chapter 11 of your textbook, that is Metal Casting Processes, and the chapter 13 of your book, that is Shaping Processes for the Plastics. So it is dealing with these metallic and the plastic parts. Now for the second CLO, it is compare between different types of metal forming processes and differentiate between their output products. So we have sometimes for making a single product we have different manufacturing processes. So, and it depends upon the type of application we have for that particular part. So you not only need to learn about the type of manufacturing process, but you should also be able to identify the advantages of various manufacturing process over others. So this CLO will cover chapter number 18, 19 and 20 of your textbook. Chapter number 18 is the fundamentals of metal forming. Chapter 19 is pearl deformation process, a very large chapter, you can say, lengthy chapter, and chapter 20 is sheet metal working. So this is the main process, and these are the subtypes of this metal forming. Bulk deformation and sheet metal are the subtypes of this metal forming. So this makes up our chapter CLO number 2. Now moving towards CLO 3, we have describe different types of joining processes and introduce concept of sustainable manufacturing. So we need to discuss the joining processes. So in this CLO we will cover chapter number 29, 30 and 31 of your textbook, that is fundamentals of welding, the main joining process which you must be familiar with, welding processes, brazing, soldering and adhesive bonding. Now moving towards CLO 4, it includes 5 lab sessions of welding and 1 lab session of casting. So we'll perform casting in a group. Inshallah, I will let you know the schedule, how we perform that. As you know, you are not allowed to visit the university, but I will try to get approval for these particular lab sessions. So make sure you don't miss it, because once you miss it, I will not be able to get approval again. Okay, make sure you are available on the dates that we will decide in the future. And the 5 lab session, which will be the individual task, and the casting will be the teamwork. So 5 lab session of welding and 1 lab session for the casting. So it makes up our CLO4. Now moving towards the assessment, what will be the assessment modes? In marks distribution, we have 20 marks for the midterm examination, that will comprise of CLO1 and CLO2. And CLO1, you know, that's about the metallic and the plastic shaping processes parts, and the CLO2 is the manufacturing process, different metal forming processes. And then the assignment quiz of 10 marks from CLO1. I think we should also write it. It also includes CLO2. Okay, it might also include CLO2 as well. So either I will give assignment of 10 marks, or you will have the quiz of 10 marks, or I can distribute assignment or quiz 5 marks each for CL1 and CL2. Okay, so you should be prepared accordingly. Then we have workshop activity for CLO4, that comprise of 10 marks, and the final examination of CLO1, 2, 3. Okay, so we'll get at least 2 chance of each CLO. CLO4 has 2 activities, so we have 2 activities for this one. Okay, and the main thing, if you want to score good, not just pass in this subject, you should have a habit of reading book. I will make a paper a little bit tricky, so you should have habit of reading book. I will refer to the book again and again in this lecture series, so that you should have habit of going towards the book instead of relying on the notes. My notes will not help you in scoring good. They will help you in passing the subject, but not help you out in scoring good in the subject. Now let's formally start with our main topics by organizing our whole course. So this chart of yours, this one, it organizes our whole subject. As you can see, we have the manufacturing processes here. It has 2 subtypes: the processing operation, in which we get the initial shape of the part, and the assembly operation, in which we have multiple parts which are already ready, then they are assembled together. In the processing operation, we have the type in which we give the shape to the material, the type in which we increase the properties of that already produced material or part, and the process in which we only alter the surface of that manufactured part. Then we have solidification. Among the shaping process, we have the particulate processing, we have the deformation process, and the material removal. In the property enhancement, we have the heat treatment. In the surface processing operation, we have the cleaning and the coating. You must be familiar with these. You have seen at your homes as well. Then in the assembly operation, we have either permanent assembly, or the mechanical assembly, or the temporary assembly. You can see here the solidification one. This topic of solidification, it covers CLO1. Then we have a deformation one. It will cover CLO2. It's a big topic. This deformation process, it will cover CLO2, and it's a lengthy one. We are not going to deal with this one, although it's very important, but we will deal with this in the next semester, probably in the materials metallurgy subject. Then we have the material removal. You will discuss in the next semester as well, this one in the manufacturing process 2, or the production engineering 2. Then we have the heat treatment. They will be partially discussed in this subject along with this one, probably with the CLO2, right? and in the details you will study in the next semester. Then we have welding, brazing, soldering. These assembly processes, they comprise of ClO3, right? And the ClO4, it's a workshop. So this is how you can remember your course. If you have a firm grip over this chart, if you are able to recognize this chart and remember the workflow in this chart, you will be able to have a good grip over your subject. What is manufacturing process? Let's start with it. So it's derived from the Latin words, the manus, hand, and factus, make. Something made by the hand. That's called a manufacturing. Although today it has been automated, but its origin started by making parts using hands. So what manufacturing actually is, it involves application of physical and chemical process for what? To alter shape, geometry, properties, and appearance of a given starting material. And what is the purpose? To turn it into a useful and valuable product. So we have certain starting material and it goes into the factory. We use some machine over that material, and with the machine we use some tooling, and we consume some electrical or thermal power, and some labor is involved, and we have some scrap material, the waste material, and we have some processed part. So this part has a greater value than this starting material. Customer will be buying this part with a greater value compared to this starting bulk material. So this is what the manufacturing is. It involves application of physical and chemical processes to alter shape, geometry, properties, and the appearance of the given starting material and turn it into a useful and a valuable product. It also includes assembly of multiple products to get something useful. So we don't only produce the part in the manufacturing process, we might also assemble multiple parts together to get certain product. Like the automobile or the jet planes, we have multiple products that are assembled together to get the final product. It is also always performed as a series of operations. Each step bring the material closer to its final product. So you have seen, like in the case of the assembly line, so it is performed stepwise, and with each step it increases the value of the product. So we have the semi-finished product, we have the finished product. So it goes from one workstation to other workstation, and at each workstation we have certain process performed. Let's suppose someone is drilling at this station, other one is welding at this one, someone is riveting, and so on and so forth, right? So with each step we add value into the material and we get the final product. Now these manufacturing process can be classified based on the type of industry we have. Now these manufacturing processes can be classified based on the type of industry, based on the type of product it is manufacturing, based on the quantity of the product, based on the material it is dealing with, and the processes that is being performed. So about the type of industry we have, manufacturing industries comprises of enterprises and the organizations. So the manufacturing industries, they are comprised of enterprises and the organization that produces or supply goods and services. So they can either produce or they can either supply goods and services. So based on these industries can be classified as a primary industry, secondary industry, and the tertiary industry. So primary industry, they cultivate and exploit the natural resources such as agriculture, mining, right? So they are the primary industries which take out the natural resources from the earth or from by other means. So they exploit the natural resources. They are the primary industries. So this is not the domain of our subject. They are mostly concerned with the metallurgical scientists or the material scientists, metallurgical one mostly. Then we have the second industry. Once we have let's suppose any natural resource extracted out from the earth, it goes into the secondary industry. They take out the output of the primary industry and convert them into consumer and capital goods. So secondary industry either forms the consumer good. They make two types of products, either from the consumer good or the capital good. I will discuss what these two are. The word manufacturing mainly applies to these industries. So manufacturing is mostly used for secondary type of industry, because these one are the mining industry or the agriculture industry. They are not mostly manufacturing, but the manufacturing mostly applies to secondary type of industry, in which they take the output of this industry and convert it into a consumer of the capital goods. Although the construction and the power generation industry are also secondary type of industry, but they are not the manufacturing industries. Okay, they are also considered as the second industry, but we don't classify them as the manufacturing industry. The third one, the tertiary industry. These constitute the service sector of the economy, like those providing the service in the economy, like banking sector, insurance, communication. We have education, like the universities, transportation, tourism. These all are the service industry, tertiary industry. While in the case of the secondary one, we have the building materials, chemicals, we have the textiles, rubber, tires, fabricated metals, steel mills, all those. And in the primary one, we have the livestock, farmings, mining, quarries, petroleum, forestry, agriculture. These are the primary industries. Now, moving towards the second mode of classification for the manufacturing. The first was based on the industry. We have the primary, secondary, and the tertiary industry. The second mode for the classification of manufacturing is the type of product that is being made here. So the final product of manufacturing industries can be divided into two types: the consumer goods and the capital goods. Consumer good includes the products directly purchased by the consumer. So such goods which are directly purchased by the consumer, they are termed as a consumer goods, such as car, computers, sports material, tires, mobile phones, etc. Whereas the capital goods, these are purchased by companies to produce goods or to provide services. So such products that are formed in the secondary industry, which are purchased by another industry to produce another good or to provide service to the consumer, they are termed as a capital goods. For example, aircraft, consumer, the passenger don't buy the aircraft, instead the company buys the aircraft to provide service to the passengers. Same in the case like medical equipments and other one. Here you can see the difference between the consumer and the capital one. This one is a consumer, jewelry, textile, and some others. They are directly purchased by the customers, whereas the tractors or the aircrafts or the trucks, they are purchased by another industry to provide service to this consumer. So this is the second base of classification for the manufacturing. So manufacturing can be classified based on the industry. You will find out, okay, what kind of industry is this? Either it's a primary, secondary, or the tertiary. If it's a secondary, you will find out what kind of secondary it is. Either it is making the consumer product or the capital product. Once you have determined this one, it is making, let's suppose, consumer product. You will identify what is the quantity of that one. So this industry can be classified based on the quantity of products or the variety of product that is being manufactured here. Quantity of product made by factory has an important influence on the way its people, facilities, and processes are organized. Right? Let's suppose a large aeronautical complex makes only 2 aircraft per year. So the way the machineries and the labor are arranged is different than the factory where the matchstick is being made, which makes up approximately millions of matchstick in a single year. Right? So it has different arrangement of machinery and its human capital. So annual production quantities can be classified as low production quantity, in which the range is 1 or 100 products per year, like in the case of aircraft. We have the medium quantity range. We have either from 100 to 10,000 units per year. You can say the automobile sector, it's a medium one. We have the high production quantity that range from 10,000 to million units per year. As I quoted earlier, it's maybe matchsticks, right? So you have the matchsticks here. So this is a third base of the classification. Now the fourth one is based on the type of material we have. In this subject, although we will be dealing with two of them, engineering materials, we have four major engineering materials. So the manufacturing can be classified based on these four materials. Either the industry will be dealing with the metals, like in the case of steel mills, it will be dealing with the ceramics, or the polymer industry, chemical industry, or the sorry for this one, it will be dealing with the polymers or the composite material. So in this subject we will be dealing with some metallic and some plastics, polymers, while these two we will deal in next semester in probably ME 209, if the code remains same in the next semester. So we will deal with these two, ceramics and the composite, in the next semester, right? And the last one, it can be classified based on the processes that are involved here. So manufacturing processes are performed as unit operation, that is, single step is performed in the sequence of steps to transform the required material into finished goods. So manufacturing processes are not performed all at once either. Instead it is performed stepwise. So it has two categories, as we discussed briefly earlier. It has a processing operation and the assembly operation. Again we are dealing with this graph. What are the processing operation? Basically, processing operation uses energy to alter work part, shape, physical properties or appearance to add value to the material. So mainly manufacturing occurs at this one. The applied energy may be in the form of mechanical, electrical, thermal or chemical. So processing operation mainly deals with the transformation of material, geometry, shape, properties and the appearance, while assembly operation, the second one, it joins two or more already finished products, right? So we have already finished products here and we will join them together to get certain product out of it. So you can see here we have three types of processing operation. So what are the three types of processing operation? You can see here the shaping one. From the primary industry, which extract ore from the earth crust, let's suppose, that is supplied to the secondary industry. Let's suppose we have foundry here. You know what the foundry is? We have the foundry here. So this foundry take this ore as an input material and perform certain operations. It can make two types of products mostly in the manufacturing, secondary manufacturing. Either it's a semi-finished good, which we named as a capital goods, or we have the finished goods in this form. So our subject is concerned in this kind of industry, right? We'll be dealing with this, what's happening inside this industry. So it takes the mineral ores from the primary industry, it processes it, adds some machining operation here and forms the final product like this one. So the shaping operations, the processing operation has three main types: the shaping one, property enhancement and the finishing operation. What is the shaping operation? It alters geometry of the starting material by various methods such as deformation, particulate processing and the machining. It only alters the shape of the starting material without changing its properties. That is the shaping operation. Then we have the property enhancing operation. It alters whatever the shape we have achieved here. We enhance the property of that material which is already given some shape. So it enhances the property of that material without altering its shape. So in this process we don't change the shape. Instead, whatever the shape we have achieved here, we simply change its properties. How do we change it? We change it by using the heat treatment operation, and you will see what are the heat treatment operation in the lectures ahead. Then the last one, surface finishing operation, you must have seen at your homes that in the iron grills you coat some zinc oxide to protect it against the corrosion or the environmental effect. So this is the same thing, surface finishing operation, to clean, treat, coat or deposit material over the surface for protecting against corrosion and the friction. The only purpose is to protect the surface of the material. So we have certain shaping operations as well. First one is solidification one. We can change the shape of the starting material using these four methods. The first one is solidification one, which is the first step also, in which the starting material is heated to liquid or semi-liquid and that cools and solidifies to form a part of the material. Let's suppose we have, if you see here, we simply heat the material and in the furnace. Once it is molten, let's suppose that in the case of iron we heat the iron until it's in the molten form, and we simply pour the molten iron into the mold cavity until it achieves the desired shape. In the second type of the shaping operation, that is a particulate processing, it is also known as the powder metallurgy. It is also known as the this one. It is also known as the powder metallurgy. If you see here, okay. So what here, starting material is in powder form. Instead of the large blocks of extracted material from the earth, it has material, either iron or any other metal, in the form of powder, and that powder is poured into the any mold cavity, whatever the shape we want to achieve. Let's suppose we want to achieve this shape, so it will be filled with powder, and then the very high pressure is applied from above, as well as heating, as well as heat. So after some time it takes the shape of this cavity. This is called the powder metallurgy or the particulate processing. You can see here this one. We have starting material in the powder form. Instead of the liquid molten material, we place it into the die cavity or the mold, and we apply the force and the heating until we achieve the desired shape. The third one is a deformation process, in which starting material is a ductile solid which is then deformed to get the final geometry of the product. And how do we do it? Let's suppose we have the starting material and ductile material. We apply the forces until it achieves the desired shape. Like in the case here, a metallic block was placed here, then we apply huge amount of force from this side until that material will squeeze out of this opening to achieve this hollow pipe geometry, or in this case of punching. There's a question for you: why brittle material can undergo deformation process? And you have to answer me in the next live session why the brittle material can undergo deformation process. So why the brittle material can't undergo the deformation process actually, right? Then the fourth type is the manufacturing process, material removal process, in which material is solid, either ductile or the brittle, from which material is removed, so the resulting part is a desired geometry. So you have large blocks from this method, then these large blocks is sent to the deformation factory, in which you further perform some operation. You have certain shape, let's suppose like this one, and to have precise dimension you use the lathe machine and other machining operation. Lathe or the milling or the drilling, use some machining operation to have precise geometry of this material. This one is called the material removal process. So it doesn't alter the geometry greatly, but it changes the dimension of the material. So these four altogether makes up the shaping operation. The first one is solidification one, then we have the particulate processing, we have the deformation process, and the material removal process. Then the second type of the manufacturing process, the second branch, you can say the second branch of the manufacturing process is the assembly operation. In the assembly operation, we have either the permanent joining processes, or we have the temporary or the mechanical joining process. What are the permanent joining process? In which joints which are formed cannot be easily disconnected, and if they are disconnected, it cannot be done without damaging the material. Either the joints are so strong that they cannot be disconnected, and if we disconnect them, it will damage the material, such as welding, brazing, soldering, adhesive bonding. And you can see when we break the weld, it also damages the parent material. Or we have the temporary joining process that are classified as a mechanical joining process. These joining techniques allow easy disassembly. So if you want to remove two parts, you can simply unscrew that and you can disassemble them. So they allow easy disassembly of the components such as screws, bolts, rivets, etc. So this is the material removal process. We didn't see that time. So we have some lathe cutting operation, we have some drilling one, and milling operation. So this is a lecture, first lecture of this subject, and if you have any question about this topic, you may message me at the Google Classroom. I will share the slides and the video lecture with you. So this is the end of this lecture. Should you have any question, you may reach me at the Google Classroom. Assalamu alaikum.